Section 4.5, problem number 31. It shows us the world population in table 39. And then it says below that table, let P equal F of T be the world's population in billions at T years since 1900. The first thing they want you to do is use a graphing calculator to draw a scattergram. Then B says find an equation of F. Now, whenever we find an equation and we have a table of data, don't forget we're not going to do it by hand, but with the calculator, and we're going to use a regression. So from this point forward, you will not be doing it by hand, therefore you'll get a slightly different answer than the back of the book. C talks about what is the p-intercept, what does it mean, we'll talk about that in a second, and finally D, find F of 114. So let's go ahead and create the scattergram. Again, first step is to enter data. We would do that the same as we did when we were talking about lines, which is stat, edit, and here we are. Now, the data starts at year 1930. However, it says to use since the date of 1900. Therefore, I will enter 30, 40, etc. Next, the population in billions, 2.070, 2.295, etc. Once the data is entered, we are now ready to draw our scattergram. Again, you need to have stat plot on, so I'll go show you that mine is on. Oftentimes you want to turn those off with number 4 here, plots off, because sometimes it interferes when you're graphing. It gives you an error. If you don't have it on, you'll just push enter here, and you will need to move off of off over to on and actually hit enter. Once you have that, you can do zoom and go to the bottom. It's zoom stat. So there we are. Looks like I have a y equals as well, so therefore drew that. I can clear that here in a second. Notice that because we have the bending effect, it would be better to use an exponential function. For a line, you would simply have to have the points being bouncing above and below the line. This has most of the points that would be below the line. So we definitely will use an exponential curve. Next, we'll find the equation. Let me remove this real quick. To find the equation, we still use stat, but now we use calculate. Now that we know, I'm going to the bottom first. Now that we know that it's an exponential regression, we will go to 0. From right here, we could just push enter, but because I'm going to be using that equation, I want it to go into the y equals. At this point, if you have a TI-84, you would need to go down to where the output goes instead of the calculate. And then you would do the same thing here. So we'll do vars, y vars, function is correct, I will press enter, and we want to go there, enter, and at this point you also have to push enter. It's generated it, and there you have it. So in the y equals, you can see that it moved it. They did mention to write the equation. Let's see, it does not say how many decimal places. Let's put it to 3 decimal places. I'll put it on the screen here. So it's 1.205 times parentheses 1.016 into parentheses raised to the t. So there's the equation. C, what is the p-intercept of the model, and what does it mean in this situation? It's important that you understand what a p-intercept is. So let's just graph that real quick. If I had a graph of the data, then because it gave me the p as being f of t, that means it's the y-axis. And this would be, the t would be the time since 1900. So therefore, the p-intercept, to find it, I'll use my calculator here in a second, but the p-intercept is where a, well, it's the value of a. So since it's the value of a, it would be 1.205 in that equation. And what does it represent? It represents the world population that initial year of 1900. So this is basically the year 1900. So there you are. Next, find f of 114. What does it mean in this situation? Well, f of 114 would be what is the population in the year 1900 plus 114, which is 2014. So it's the population in 2014. We can just use table. So I'll use second table. You can hit the delete key here. So I'm just going to do that to get rid of these. And then now I'll just put 114 in, and we get 7.5 out. And so that would be the world population, and that is in billions. So 7.5 billion people in that year is what you would predict. So there you have problem number 31.